standard second year physics waves chapter, important 8 marks question. In the previous video we explained 2 important questions for 8 marks. Now third one, most important one. How are stationary waves formed in closed loop? So how are stationary waves formed in closed pipe? Explain the various modes of vibrations and obtain the relation for their frequencies. So what is a closed pipe? A cylindrical pipe opened at one end and closed at another end is called closed pipe. So like this, it is a cylindrical pipe. This end is closed and this end is opened. This is a closed one and this is a open one. So open end, opened end and closed end. So this is called closed pipe. Now the closed pipe also has a air column. Here air is present. So when the compressional wave, that is sound wave, is sent through the closed pipe, the wave gets reflected from the ends, forming incident and reflected wave. When a sound wave is sent through this closed pipe, from the end the wave gets reflected, forming incident wave and reflected wave. So these two waves having same frequency traveling in opposite direction along the length of the pipe can overlap. So that is can superimpose to form longitudinal stationary waves. So like this, it is a closed end, it is open end, longitudinal stationary waves like that formed. So these waves are due to incident and reflected wave traveling in opposite direction along the length of the pipe in the air column. On overlapping, these are formed. Next, to formation of harmonics in the closed pipe. First one, fundamental frequency. It is a closed pipe. When we send a sound wave through this closed pipe, the air column in the closed pipe will vibrate with fundamental frequency. So in the fundamental mode of vibration, open end always no antinode is formed and closed end node is formed. So in the fundamental mode of vibration, one antinode at open end and node at closed end are formed. ఇక్కడ చూస్తే ఇది ఓపెన్ ఎండ్, ఇది క్లోజ్డ్ ఎండ్. ఓపెన్ ఎండ్ ఎల్లప్పుడూ యాంటీనోడ్ ఫామ్ అవుతుంది, క్లోజ్డ్ ఎండ్ ఎల్లప్పుడూ నోడ్ ఫామ్ అవుతుంది. సో హియర్ యాంటీనోడ్ నోడ్, number of antinodes 1, number of nodes 1 in the fundamental mode. So let the wavelength, distance from antinode to node is lambda by 4. In the first case we are taking this one lambda 1 by 4 and here to here length of the air column is L. So let wavelength is lambda 1, frequency is N1, length of the vibrating air column is L. So from the figure, L equal to here to here L, here to here lambda 1 by 4. So L equal to lambda 1 by 4 by the cross multiplication, lambda 1 equal to 4L. We know speed of sound wave V is equals to N lambda. But here N is taken as N1, lambda is taken as lambda 1. So V is equals to N1 into lambda 1, then N1 is equals to V by lambda 1. Lambda 1 means 4L. And substituting N1 is equals to V by 4L. So here N1 is called fundamental frequency, or it is also called first harmonic frequency. Next, third harmonic frequency expression, students. That is the length of the pipe increases, length of the vibrating air column also increases. In this mode of vibration, two antinodes, two nodes are formed. In the first case, students, number of antinodes, number of nodes 1, it is the first case. Next to two antinodes, two nodes in the second case. In the third case, three antinodes, three nodes. So ఇవి గుర్తుపట్టుకుంటే మనం సింపుల్గా రాసేయచ్చు. ఓపెన్ ఎండ్ ఆల్వేస్ యాంటీనోడ్, క్లోజ్డ్ ఎండ్ నోడ్. యాంటీనోడ్ తర్వాత నోడ్ వస్తుంది, నోడ్ తర్వాత యాంటీనోడ్, క్లోజ్డ్ ఎండ్ నోడ్. సో ఇన్ దిస్ మోడ్ ఆఫ్ వైబ్రేషన్ టూ యాంటీనోడ్స్ అండ్ టూ నోడ్స్ ఆర్ ఫార్మ్డ్. So let wavelength is lambda 3, frequency is N3, and you know here to here this is a lambda by 4, this is lambda by 4, this is lambda by 4. So lambda by 4, lambda by 4, lambda by 4, 3 times. So 3 lambda by 4, but in this case wavelength is taken as lambda 3. So that is lambda 3, frequency n3, length of the air column here to here L. L is equals to 3 lambda by 3 lambda 3 by 4. Cross multiplication cheste 3 lambda 3 is equals to 4L, then lambda 3 is equals to 4L by 3. We know that speed of sound wave V is equals to n lambda. But here n is taken as n3, lambda is taken as lambda 3. So then n3 is equals to v by lambda 3, then n3 is equals to v by lambda 3 means this is 4L by 3. So now n3 becomes 3 of v by L is a simplification. But we know that from equation 1 v by 4L is v by 4L equal to n1. So n3 is equals to 3n1. This n3 is called to third harmonic frequency or first overtone. Next to fifth harmonic frequency. Students, again length of the pipe is increased, length of the air column is increased in the pipe. So now in this mode of vibration, 3 antinodes, 3 nodes are formed. Antinode, node, first to top. Antinode after node, node after antinode, node, antinode, node. Here to here, lambda by 4, lambda by 4, lambda by 4, lambda by 4, 5 times. That is why 5 lambda by 4. So this wavelength is taken as lambda 5. So length of the vibrating air column is L. So L is equals to this length equal to this wavelength, that is 5 lambda by lambda 5 by 4. So L is equals to 5 lambda 5 by 4. So in this mode of vibration, 3 antinodes, 3 nodes are formed. 1, 2, 3 antinodes. 1, 2, 3 nodes. So let wavelength is lambda 5, frequency is n5, length of the vibrating column L. So from the figure L is equals to, we can understand 5 lambda 5 by 4, then lambda 5 is equals to cross multiplication. Students, cross multiplication and simplification. 5 lambda 5 is equals to 4L, then lambda 5 is equals to 4L by 5. So we know that speed of sound wave V is equals to n lambda. N means n5, lambda means lambda 5. Then n5 is equals to V by lambda 5. So but here lambda 5 is there, that is 4L by 5. So in the place of this is written. N5 is equals to V by 4L by 5. Then N5 is equals to 5 of V by 4L. V by 4L from equation 1. From equation 1 this is equal to N1. So N5 is equals to 5N1. So here N5 is called to fifth harmonic frequency or second overtone frequency. Similarly, the frequencies of higher harmonics can also be derived. So the ratios of frequency for harmonics in the closed pipe are N1 is to 3, N1 is to 5, N1 and so on. So N1, N1, N1. Cancellation means 1 is to 3 is to 5 and so on. So in the odd numbers ratio is for frequencies of harmonics produced in the closed pipe. Most important for 8 marks.